Hey Shelby, I'm going to explain these the best way that I possibly can. I hope they make sense. When you sent me these questions, I have actually never seen questions this way. Usually it's the opposite way. It's the reverse, where like in the first question, you said the question that you sent me, they were asking for micrograms per kilogram per minute, but you were given milliliters per hour. Normally, it's the opposite way around, that the ordered dose is so many micrograms per kilogram per minute, and you have to figure out milliliters per hour. And the same thing with the other question. Typically, the ordered dose is so many units, and you have to figure out what that is in milliliters per hour. So I pretty much just did the reverse of how I normally teach these questions, so I hope they make sense. I understand the dimensional analysis that people use, but I understand that that way can be confusing too. So I'm going to start with the second one because the second one's a little bit more straightforward. It's a little bit easier. The one where it says that you've been ordered to infuse heparin, so I'm going to just write down the numbers that we have here, 9.5 milliliters per hour. You have a supply that is a solution of 2,500 units. I'm just going to put units per 250 milliliters. Okay, so the question is asking us how many units per hour are we going to give. So here's what I do on these. Typically, again, in just showing this, typically this is what's ordered and we need to solve this. So again, I just kind of did the reverse of what I'm used to doing. So what I mean by that is, typically we use that D over H times Q formula where the order dose is, again, typically units per hour. And just let me write this up here again, reminding that D is the order dosage. Oh, whoops, it's supposed to be a Q. D is the order dosage, H is the dosage that we have on hand, and our Q is the quantity that we have on hand. So in this problem, I'm going to write the H and Q here in blue. In this problem, our H and Q are given to us. That's what the supply always is. So 2,500 units per a quantity of 250 milliliters. So that's how we do that D over H times Q formula. The problem is, it's really not going to work out. No, I want to make sure. The problem is the ordered dose, 250, is in milliliters this time. So what's been given to us is really kind of the answer, is how I looked at that. Because I'm used to using that ordered dosage, which is kind of what's being asked here, is what's the dosage that this person is getting per hour, not the milliliters per hour. So how I treated this problem, and this might look really strange, I put that we're trying to solve this, so I used X in place of our ordered dose, since that's what we're trying to figure out. And that the answer, and I'm going to put equals 9.5 milliliters per hour. Let me actually open up a new screen so you can see that a little bit better, or get all of this stuff out of the way here. Okay, so again, here's how I set this up. I put it as X over 25,000 units per 250 milliliters, sorry, that's a 5. And I put that that's equal to 9.5, which is what we got. We know what it is in milliliters per hour. I hope this looks familiar to you and you're remembering that D over H times Q and how typically D is the ordered dosage. So here's what I did. When you have some type of linear equation like this where you're trying to solve for X, and again, here's our X. We're trying to solve for that number. Typically, your idea is to get X on one side of the equal sign so that it then says X is equal to your answer. So the object is to get what's sharing that same side of the equal sign, so that would be, again, our 250 milliliters and our 2,500 units. You have to get rid of those and move those to over on the other side. Oh, sorry, I meant to draw arrows and mess that up. So you're trying to get those to the other side of the equal sign so that you have this very situation, that X is equal to something. So what I did, and what you do when that happens in a in a linear equation like this, is you have to do the opposite in order to get it to the other side. You have to do the opposite of what's being done. So what I mean by that is, like for instance, since 250 right here is being multiplied, I divided it. In order to figure that out, that's going to help get rid of it. And again, I've gotten this all over the place, and so all of this is not going to make any sense when I have all these x's. And so again, let me rewrite this. So sorry. X over 2,500 times 250 is equal to 9.5 is what we have here. So you have to divide. So I divided that because what that does when you divide by 250, that's going to cancel that out over here because you're doing the opposite of what's currently being done. But remember what equals means. So everything on the left side of the equal sign right now is equal to the right side of the equal sign. So whatever you do on one side, you have to do to the other, is essentially what I'm doing here. So what that leaves us with then is still the x over 2,500. And then on the other side, 9.5 divided by 250 is 0.038. I know that looks so weird, but now we have to get rid of that 2,500. The 2,500 is currently being divided, so it's x divided by 2,500. So to get rid of it, we have to do the opposite. So we multiply by 2,500. So I'm running out of space here, so I'm going to multiply by 2,500. That's 5. Because again, that's going to cancel that out and leave me with x by itself, the object of what I'm trying to do here, so that it says x is equal to my answer. So I'm going to do the same thing here, because again, we've got to do the same thing on both sides of the equal sign, and that's what I had to do here. So 0.038 times 2,500 is 950. So we get 950 units. And since the original order dose was per hour, this is also still per hour. So we didn't have to really do anything different with that. And if it helps, you can always go back and double check your answer. As you know, again, if the order dose is 950 units, then that means when I go to plug it into that D over H times Q formula that we're so used to seeing, well, that means that the order dose, 950 units, sorry, I keep doing that, units, over the supply, 25,000 units times 250, well, 950 divided by 25,000, then times 250 is 9.5. And so that's how you get it out of units and into milliliters. Because remember how that works is since D and H are the same unit, since they're both units, they cancel each other out. And it leaves us with what our quantity unit is, which is, again, milliliters. So that's why we were left with the answer of milliliters. So that's a way that you could double check. That's the way that I looked at it. I hope that makes more sense than the dimensional analysis, as that is, again, just we're used to that D over H times Q formula, and that was just the way that I approached that. Now taking a look at that other one, the other one's pretty complex. Typically what happens here is I'm so used to, again, going the opposite direction. So I want to show you what happens if I was ordered that first. Let me show you what I mean. So if I was ordered, I know we know that this is the answer, 2 micrograms per kilogram per minute. Then here's what we typically do for a problem like this, because this is what we're used to seeing, and this is what typically is how it's given on ATI exams too, that you're given this type of question and you're trying to calculate milliliters per hour. So the idea is to incorporate the patient's body weight. So I think, okay, well, if a patient is getting 2 micrograms for every kilogram, for a patient that weighs, what was that patient? 105. For a patient that weighs 105 kilograms, if I take 2 times 105, so 2 times 105, that means this person is going to need 210 micrograms every minute. Then thinking a little bit further into that, now that it's micrograms per minute, again, there's 2 more things that need to be done. I need to get my micrograms into milliliters, and I need to get to my minutes into hours. How you convert any type of dosage into a liquid is through that D over H times Q formula. So D over H times Q. How you get minutes into hours? Well, there's 60 minutes in an hour, so that's always going to be times 60. Doesn't matter which one you do first, but I just want you to think about this a little bit further. So if a patient needs 210 micrograms every minute, well, 210, there's 60 minutes in an hour. So if you're getting 210 micrograms, which with each of those minutes, well, that would be 210 times 60 to show what they're going to get in a full hour. 210 times 60 is 12,600, still in micrograms, every hour. So again, now we've got it in micrograms. The idea is to get it into milliliters. Well, if it helps, since the supply that was given to us was 50 milligrams, I went ahead and converted this into milligrams. Remember, micro to milli is moving the decimal 3 places to the left. So that means, again, all I've done is convert that micrograms into milligrams. That's 12.6 milligrams every hour. But I want to see what it is in milliliters per hour. So I need to put that into a dosage formula. So since my supply was 50 milligrams per 250 milliliters, I will now then convert this into milliliters. So 12.6 divided by 50 is 0.252, but times 250 gives us 63. So it's 63 milliliters per hour. Again, I thought this question was kind of weird in that it gave us this first and then asked us to go the other direction. So let me show you how I approached that then. Because again, that's typically what you'll see is what you have on the screen here. Is typically it's ordered that way and then you're trying to calculate the milliliters per hour. So since your question kind of asked the reverse of that, that's how I thought about it is, okay, well, how would I do that problem in reverse then? So since the ordered dose was 63 milliliters per hour, what I did is, again, I just pretty much did the opposite of what I typically do. So remember the last step that we just finished with was the dosage calculation, the D over H times Q. So again, I kind of did in what we talked about on the first one, I acted like, again, I don't know what that ordered dose is, but I do know the supply comes as 50 milligrams per 250 milliliters. And I know that that should give me 63 milliliters per hour, what I did at the end there. So I did exactly what I did in that last problem. I have to, again, get rid of 250, so I have to do the opposite of what's being done. So I divided by 250, and I did that on both sides. And that left me with x over 50 is equal to 63 divided by 250 is 0.252. So again, you're seeing the reverse of what's happening here. Now taking that and multiplying both sides by 50, because that's going to help me to cancel out this 50 here. That's going to help me get rid of that and show me that x is equal to is 12.6. So what this shows me now is that the ordered dose is 12.6, again, milligrams per hour. All I did was converted the milliliters into milligrams, the reverse of what I did on the last example. So we now have 12.6, so 12.6 milligrams to be administered every hour. Just like I did on the last one, I just did the opposite here, that again, I'm trying to figure out what this is in micrograms per kilogram per minute. So again, I'm just doing the opposite of what I did in the last problem. So what I did was I said, okay, well, if that person's getting 12.6 milligrams every hour, well, that's the same thing as 12.6 milligrams. Oh, sorry, didn't recognize my finger there. In 60 minutes, right? Since 1 hour is the same thing as 60 minutes. So what I can do, if I take 12.6 and divide it by 60, that shows that this person is going to get 0.21 milligrams every single minute. So that's just a different way that I wanted to approach that and look at that. And again, keeping in mind that I want it to be in micrograms, again, if we could just convert the milligrams into micrograms, milli to micro is times 1,000 or 3 places to the right. So that would be the same thing as 210 micrograms every minute, right? So I've already done this. I've already got it into micrograms. I've already got it into minutes. But I just need to see what that would be based on the weight of my patient. this person is getting 210 micrograms every minute, but I want to know what that is per kilogram, per the kilogram weight. So what I did was I just took that and divided it by my patient's weight, and that would tell me exactly that. 210 divided by 105 shows me that this person is needing 2 micrograms per each kilogram each minute. So again, I just did the reverse of what I'm typically used to doing. So I hope that helps. Let me know. I can try to think of a different way to explain it if it doesn't, but I hope it at least helps more than the dimensional analysis. I do have more videos. If you go to my I'm sorry, not my Facebook, but my YouTube page, if you go to YouTube and search Ellie Michael, you should be able to find, I've got more videos on, again, the reverse of this question, where it starts with the order dose is this, and I need it to be in then try to figure out what that is in milliliters per hour. So I have more examples with those if you want to see, again, the reverse of this question, and maybe that would help some more with that. But let me know how you feel after this. Thanks, Shelby.